There is a moon orbiting Jupiter. You've probably heard of it. Scientists have talked about it for decades, politely, carefully. The way you talk about something you don't fully understand yet. But in the last 18 months, the most powerful space telescope ever built has been staring at this moon, quietly, patiently, pulling back a curtain that has been frozen shut for billions of years. And what it found was not what anyone predicted. This is Europa, and it has been hiding something from us. Europa is one of Jupiter's 4 Galilean moons, discovered in 1610 by Galileo himself. It's slightly smaller than our own moon, about 3,100 kilometers across. From the outside, it looks like a cracked egg. The surface is almost entirely water ice, crisscrossed with reddish-brown streaks and ridges, stretching for thousands of kilometers in every direction. Beautiful, strange, and completely frozen. For a long time, that's all we thought it was. A frozen wasteland, a smooth ball of ice orbiting Jupiter. Pretty in photographs, unremarkable in every way that should matter. But in the late 1990s, everything changed. NASA's Galileo spacecraft measured something unusual: disruptions in Jupiter's magnetic field near Europa. Disruptions that could only be explained by one thing: a vast body of electrically conductive liquid beneath the surface. Salt water, an entire ocean of it, likely containing more water than every ocean on Earth combined, sealed under a shell of ice. That ocean is what made Europa famous. Because where there's liquid water, there's at least the possibility of life. Not a guarantee, not even a strong hint. Just a door, left slightly open. And for 20 years, that open door was all we had. We couldn't see through the ice. We couldn't taste the water. We couldn't measure what was happening down there. We were stuck outside, pressing our faces against frosted glass. James Webb changed that. Not by drilling through the ice, not by landing a probe, but by doing something deceptively simple: staring at Europa's surface with the most sensitive infrared instruments ever built. In September 2023, 2 independent research teams published results from Webb's near-infrared spectrograph, an instrument so precise it can identify individual molecules on a surface, more than 600 million kilometers away. They were looking for one thing in particular: carbon dioxide. Not because carbon dioxide is exciting on its own, but because of what it would mean. Carbon dioxide on Europa's surface could come from 2 sources: meteorites or radiation from space, or it could come from inside, from the ocean itself, pushed upward through cracks in the ice, and deposited on the surface. If the carbon dioxide came from below, it would mean the ocean contains carbon, and carbon is the backbone of every known form of life. Both teams found it: carbon dioxide, concentrated in a specific region called Tara Regio, a geologically young area of disrupted terrain. This wasn't a thin dusting scattered randomly. It was concentrated, localized, sitting in exactly the kind of terrain refreshed from below. The distribution pattern pointed downward, toward the ocean. Geronimo Villanueva, lead author of one of the studies, put it plainly: the carbon dioxide was not arriving from outside. It was consistent with an internal origin. The ocean beneath Europa's ice contains dissolved carbon dioxide, and the geological churning of Tara Regio had brought traces of it to the surface, like a stain seeping through fabric. Carbon in a subsurface ocean is a prerequisite for life. But Webb wasn't finished. In March 2024, a separate team used Webb to search for plumes, water vapor erupting into space. The Hubble Space Telescope had reported possible plumes back in 2012 and again in 2016, but the detections were shaky. Some scientists believed them, others weren't convinced. Webb looked, and this time the answer was clearer: no large persistent plumes were detected. That might sound like a disappointment. It isn't. What it tells scientists is that Europa's plume activity, if it exists, is likely sporadic rather than constant. Compare this to Enceladus, Saturn's tiny moon, which fires geysers continuously from its south pole, fed by tidal forces kneading its interior like dough. Europa appears to be different. Its outbursts, if they happen, are intermittent, possibly triggered by specific tidal stresses. as Jupiter's gravity flexes the moon's ice shell. Like a sleeping giant, that breathes once every few years. Here's the question that stops most people cold. The surface temperature sits around -160 degrees. Where does the energy come from? The answer is Jupiter itself. Europa's orbit isn't perfectly circular. It's slightly elliptical, nudged into that shape by the gravitational tug-of-war between Jupiter and the other large moons, particularly Io and Ganymede. As Europa moves closer to and farther from Jupiter during each orbit, the planet's immense gravity squeezes and stretches the moon's interior. This is tidal heating, the same mechanism that turns Io into the most volcanically active body in the solar system. Think of it like flexing a rubber ball rapidly in your hands. The ball gets warm. Now imagine that ball is 3,100 kilometers wide. The energy generated by that constant flexing doesn't just maintain liquid water. It could drive hydrothermal activity on the ocean floor. Hot vents, where mineral-rich water meets cold ocean, exactly the kind of environment where life originated on Earth nearly 4 billion years ago. Europa's ocean sits somewhere between 60 and 150 kilometers deep. For context, the deepest point in Earth's oceans, the Mariana Trench, bottoms out at about 11 kilometers. Europa's ocean could be more than 10 times deeper, contained inside a moon smaller than ours. Webb's carbon dioxide discovery slots directly into this picture. If the ocean floor is hydrothermally active, and the ocean contains dissolved carbon and other compounds, then Europa has 3 of the 4 ingredients that astrobiologists consider necessary for life: liquid water, energy, chemistry. The 4th ingredient is time, and Europa has had plenty of that. The ocean is billions of years old. None of this means life is there. I want to be careful about that. Detecting carbon dioxide on the surface of an icy moon is not the same as finding a microbe. The gap between conditions that could support life and conditions that actually produced life is enormous. We have exactly one data point: Earth. Drawing conclusions from a sample size of 1 is bad science. What Webb has done is narrow the possibilities. Before these observations, we knew Europa had water and energy. Now we know it has carbon too. Each confirmed ingredient shrinks the list of reasons to think life couldn't exist there. In October 2024, NASA launched the Europa Clipper, the most sophisticated instruments ever sent out. Over the course of roughly 50 close flybys of Europa, some passing within just 25 kilometers of the surface, Clipper will map the ice shell in detail, measure its thickness, search for active plumes, analyze the composition of any ejected material, and probe the ocean's depth and salinity using radar and magnetometry. If Tara Regio is leaking ocean material to the surface, Clipper will taste it. If there are organics embedded in the ice, Clipper's mass spectrometer will identify them. But Clipper won't arrive at Jupiter until 2030, and when it gets there, it faces a brutal environment. Jupiter's radiation belt hits Europa with roughly 540 rem per day, enough to kill a human in hours. Clipper's electronics sit inside a titanium vault, with walls nearly a centimeter thick, and even with that armor, the spacecraft can only survive brief passes near the surface, before retreating to safer distances. 50 flybys instead of a stable orbit, because parking a spacecraft at Europa would fry its instruments within weeks. Europa doesn't make this easy. It never has. One of Clipper's 9 instruments is called SUDA, the Surface Dust Analyzer. Its job, to catch and analyze microscopic grains of ice and dust ejected from Europa's surface by micrometeorite impacts or plume activity. Each grain is essentially a tiny frozen sample of whatever material sits on or just below the surface. SUDA can determine molecular composition. Clipper also carries an ice-penetrating radar called REASON, designed to map the internal structure of the ice shell down to a depth of about 30 kilometers. For years, theoretical models have predicted that pockets of liquid water could be trapped within the ice shell itself. If those lakes exist, REASON should detect them as bright radar reflections. The radiation environment adds another layer, and it cuts both ways. Jupiter bombards Europa's surface with intense radiation, charged particles accelerated by the planet's enormous magnetic field. This radiation is strong enough to destroy complex organic molecules on the surface. Within decades, any biosignature would be destroyed before detection from orbit. But here's where it gets strange. Radiation also splits water ice into fragments that recombine into new compounds, including hydrogen peroxide and molecular oxygen. Some models suggest that this radiation-produced oxygen could be cycled back down through the ice into the ocean below, where it would be available as a chemical energy source. Radiation feeds the ocean. When I first understood that feedback loop, it stopped me completely. A planet that showers its moon with lethal radiation, and that same radiation, filtered through 30 kilometers of ice, might arrive at the ocean as food. Europa doesn't play by intuitive rules. In late 2024, additional Webb observations revealed something else: crystalline water ice features on the surface. Fresh ice on a moon bombarded by constant radiation suggests recent resurfacing, material from below replacing the irradiated surface layer. And the distribution of this fresh ice correlates with the same disrupted terrain, where the carbon dioxide was found. Whatever is happening underneath the ice is still happening now. The chemistry Webb detected isn't a fossil, it's a bulletin. When researchers examined the spectral data more closely, they found that the carbon dioxide was mixed with other salts, specifically sodium chloride and magnesium sulfate, table salt, and Epsom salt. Essentially, the same kinds of salts dissolved in Earth's oceans. The ocean talks to the ice talks to the surface, and the surface talks to space. Webb caught that. There's a philosophical weight to all of this. That gets lost in the technical details. For most of human history, the question of whether life exists beyond Earth was a matter for theologians and philosophers. It wasn't a scientific question, because we had no tools to investigate it. Then we built telescopes, we sent probes, Mars, Venus, airless rocks. The question shifted. Not, is there life out there? But, are the ingredients there? That's a question you can answer with a spectrograph. That's a question Webb is answering right now. If you could somehow stand on Europa's surface and look up, the sky would be dominated by Jupiter. Not a dot, not a bright star, a wall. Jupiter would fill nearly 24 degrees of the sky, 48 times the size of the full moon. It would hang there, banded in oranges and browns and whites, slowly rotating, the great red spot drifting across its face, like a bruise that never heals. And you would feel just how small Europa is, how completely it exists, at the mercy of that enormous planet. The tides, the ocean, the radiation, all of it comes from Jupiter. Europa exists because Jupiter allows it to. What has changed, genuinely and measurably changed, because of James Webb, is the strength of the case. Before 2023, Europa was a promising candidate. After Webb's carbon dioxide detection, after the confirmation that the ocean's chemistry is reaching the surface, Europa has moved from promising to compelling. Hypothesis versus research program. Clipper will get closer. Suda will catch grains of ice, no larger than a grain of sand, and read them like letters from the deep. And one day, maybe in the 2040s, a lander will touch down on that fractured terrain, melt through the ice, and lower an instrument into water that has never seen sunlight. Whatever it finds down there, whether it's barren salt water or something stranger, will rewrite our understanding. Europa didn't ask for our attention. It kept everything hidden under 30 kilometers of ice and let us guess. For 20 years, we guessed. And then Webb looked, carefully, patiently, and Europa finally gave us something real. The ice hasn't cracked yet. Not for us, but we're getting closer. If this video made you see Europa differently, you know what to do. See you in the next one.